Hello everyone. Hopefully after that brutal merge sort tutorial I didn't scare you away, because this last video it's going to be short, easy, just kind of a little recap of what we learned in terms of the algorithm speed. So let's kind of just jump into it. Let's first look at the speed of insertion sort and bubble sort. So in terms of like a mathematical function, we're going to see that like the time of execution is equal to n squared. So time is pretty arbitrary, of course, because, you know, different computers with different processing speeds and different hardware capabilities are going to sort of run through an algorithm at different like hard times, but sort of relative to each other, the time is going to be equal to n squared. N is just equal to the input size, or the size of the data set, and then time, you can probably more aptly think of time as the number of executions, so like the number of comparisons, or just like more of just like a number like that. So let's say you had an array set of 5, so 5 squared would be 25, would be like your time, but if your n was like 10, then it would be 100. If your n was 100, that would be like something like 10,000, and so on and so on. So this really starts to grow, I'd say exponentially, but really more like quadratically over time. It's pretty crazy. So yeah, of course, n squared is a quadratic function, and this is an approximation, but this is in general what you're going to see with insertion sort and bubble sort. Merge sort, on the other hand, goes to the function n log n, and it's generally log base 2 of n, although that's not particularly important because n log n in the log run is significantly less than n squared. N squared is so much bigger, and so merge sort, of course, you'll see already is just, as I was saying, a lot more efficient algorithm once you get to the bigger numbers. So you'll see right here, the x-axis at the very bottom right down here is the data set, and then the y-axis off to the left hand of your screen, you're going to see that's like the time, you could call it. So you can see that merge sort n, just take a look at like, say like the date, like if you have just like 500 numbers, which in practice really isn't that many. If you have a large database or something, you're going to see that your merge sort time, or I guess executions you could say, is right around 4,500. Whereas bubble sort and insertion sort, man, I don't even want to know what those times are. So you can see that this has a huge impact in the long run. Merge sort is definitely more practical to use. I think bubble sort is good if you just have, say you have like a simple video game, you know, if you're into video games like I am in my website and channel, then you'll definitely, if you just have maybe like 10 characters or something you need to sort, then like bubble sort and insertion sort, totally fine, totally acceptable. Maybe even 50 to 100, you could really get away with it because computers have great speed. But once you hit like that 500 number, you really want to start like considering to use merge sort, because it's a lot more efficient in the long run. Just kind of a fun fact, Java uses this sort of approach. I don't believe it's merge sort in particular, but merge sort is part of a family of algorithms called divide and conquer algorithms. And it's called this because it was recursive, and it divided this main array up into multiple smaller arrays. So that's the divide, and sort of the conquer aspect, it would slowly merge them back together. Divide and conquer algorithms in general, of course, are a lot more quick than algorithms like bubble sort and insertion sort. That is all I have for you. I hope you really enjoyed this course. Please feel free to rate it, and I hope to see you again in the future. So thank you, and have a nice day.